This is a Mars rover project for MEC 203 in Stony Brook University. For this Mars rover project, I designed a rover called the Apex, based off of NASA's Perseverance rover. The goal was to create a rover that could move across the surface of Mars, collect samples, and send data back to Earth. And here we can see the full assembled rover. It is about 4,100 millimeters long, 2,000 millimeters wide, and about 2,400 millimeters tall. It is made up of 17 to 19 individual parts. These are some of my Mars rover designs came up with, and I came up with this just by like experimenting, looking at other Mars rovers like the Curiosity and the Perseverance. Starting with the wheels, the rover has six wheels, each 345 millimeters in diameter. They are attached to the axle using six M8 hex bolts through 8 millimeter holes. These bolt holes use an H11 C11 loose running fit, which means the bolts slide in easily and the nut and bolt the head hold everything together. The suspension connects the wheels to the body. It is based off the rocker bogie system, which means the wheels can move up and down independently when the rover drives over rocks or uneven ground. The pivot shafts in the suspension use an H7 H6 locational clearance fit. This keeps the shaft accurately in place while still allowing the small tilting movement the suspension needs. Here we can see the camera module. It is mounted underneath the chassis and can spin a full 360 degrees so it can see in every direction. The camera is secured with M8 bolts using an H11 C11 loose running fit, and it rotates freely on a revolt joint. Here you can see it spinning. The high gain antenna or HGA satellite sits on top of the rover. It is a hexagonal dish that is 633 millimeters tall with a 220 millimeter dish. It also rotates 360 degrees so it can always point toward Earth no matter which direction the rover is facing. Same as the camera, the bolt holes use H11 C11 and it rotates on a revolt joint. Here we can see the drill arm. It stands at 1122 millimeters tall and is made up of six parts: a base, an arm, and an axle, a rotating collar, a drill head, and a 960 millimeter long spiral drill bit. The drill arm pivots on a 30.23 millimeter axle shaft. The axle rotates inside the arm and collar using an H9D9 free running fit, which gives enough clearance to the arm to rotate smoothly in any direction. The bolt holes in the drill base also use a H11 C11 fit as well. Here you can see the drill moving through the full range of motion to drill some rocks. And here are the bolts here. So is are also are on the wheels too as well. And finally, here we have the claw arm. It has a total reach of 2215 millimeters and is made up of four parts: a base, a long arm, and a claw head, and the individual claw pieces. The claw arm is about 150 millimeters in diameter and rotates inside the claw base. The individual claw pivot pins are 22.5 millimeters in diameter. Both of these rotating connections use a H9D9 free running fit so the claw can move freely through its full range of motion. The bolt holes in the claw base also use a H11 C11 fit. Here you can see the claw moving. And that's about it. Thank you.